Good morning to all of you. I am Vishal Jayaswal, Assistant Professor, Computer Science Department, Ajay Kumar Garg Engineering College. And here I am going to take lecture on stack organization. That is a topic on computer organization and architecture. This is the first lecture on stack organization. If you talk about stack, basically stack is a storage device that stores the information in such a manner that the item stored last is the first item retrieved. Basically, stack follow the concept of LIFO, L-I-F-O, means last in, first out. And the item stored last, retrieved first. And the operation of a stack can be compared to a stack of trays, and the last trace placed on the top of the stack is the first to be taken off. In stack organization, there are some terminology and some registers are used, like stack pointer register. Here in this stack organization, we are going to use stack pointer register. And there are some operations like insertion, that is called push operation, and the deletion, that is called pop operation. If we talk about registers, that is registers that holds the address for the stack is called the stack pointer, because its values always points at the top item in the stack. The two operations of a stack are insertion and deletion. And the operation of insertion is called the push or push down, and because it can be thought of as result of pushing a new item on top. The operation of deletion is called the pop operation, because it can be thought of as the result of removing one item so that the stack pops up. However, nothing is pushed or popped in the computer stack. This is the basic important concept of this register. It means stack organization means nothing is pushed or popped in the computer stack. Only the things is that these operations are simultaneously simulated by incrementing or decrementing the stack pointer register. Basically, the stack pointer register is incrementing. When stack pointer register is incrementing, we can say it is a push operation, and when a stack pointer register is decrementing, we can say it is a pop operation. In stack organization, we classify this into two types, that is the register stack and memory stack. And first, in register stack, we are going to make a stack of registers that are in the processor. Here in this example, we are going to take 64 register, and this is a 0 to 63. These are the 64 registers that are used for making the stack. And here we are going to use DR register, means data register, for storing for push or pop operation. And here this is a stack pointer that points at the top element of the item. And here these are the two control flags. Basically, these are the flags which shows the stack is full or empty. Initially, if we talk about initial condition, initially SP is clear to 0, means the value of the stack pointer register is equal to 0. The value of the stack pointer register is equal to 0, and empty is set to 1. And here we are using empty equal to 1. Initially, our stack is empty, so we are going to use empty equal to 1, and full is clear to 0, means the value of full is 0. So here full flag is 0, empty flag is 1, and stack pointer value is clear to 0, means initially stack pointer points at the 0 location of the stack. This is the initial condition of the register stack. This is the stack formation, and in this way we can initialize the register stack, and after that in the register stack there are the two operations, that is the push operation. This is the algorithm for push operation, and second one is the pop operation, means this is the algorithm of pop operation. First we are going to talk about the push operation. In push operation, step number 1 is we first increment the value of stack pointer, means SP plus 1. First we increment the stack pointer value, means SP tends to SP plus 1. In this way we can increment the stack pointer register, means first stack pointer, initially stack pointer points at the 0 location, and after the incrementation the value of stack pointer point at the 1 location. And the second step is the value of dr is write into the m of sp, right item on the top of the stack. dr, the content of dr is transferred at m of sp, means where stack pointer is currently pointing, we transfer the content from dr to stack. Here stack pointer currently point out at the 0 location, and if we assume that the value of dr is a, means a is in the dr register. If we talk about dr content of dr transferred to m of sp, means a is transferred at the 1 location and a is at the 1 location. Next, if sp equal to 0, then set full equal to 1 and empty equal to 0. And in this scenario we can say that the value of a stack pointer is not 0, then we can do nothing, simply perform these two steps. First step is sp incrementing the stack pointer, and second step is transfer the content of dr into the stack. In this way we are going to perform the push operation in the register stack. Basically, if we transfer the content from dr to stack, this is called the push operation. This is called the push operation. Then at what condition the stack pointer value is 0 and then full set to 1 and empty set to 0. Let's say that our stack pointer point out at this location, and here we assume that some value, that is x. If we want to perform the push operation at this stage, where at the address 63 our value is x in the stack at address 63 and stack pointer pointing at the 63 location, then when we perform the push operation, then first we perform the incrementing the stack pointer, means sp plus 1. We perform the sp plus 1 and stored in the stack pointer register. it means 63, and the binary of 63 is 6 times 1. The binary of 63, this is the binary of 63, and we add plus 1, then we can say that 1 plus 1 is equal to 0, 1 carry, 1 plus 1 is equal to 0, 1 carry, 1 plus 1 equal to 0, 1 carry, 1 plus 1 equal to 0, 1 carry, 1 plus 1 equal to 0, 1 carry, and 1 plus 1 equal to 0, 1 carry. We discard this carry. We cannot assume this carry in the operation. So, here we can say that this is the 63, and we add 1, and we got the 6-bit 0. So, we can say that our stack pointer register move from 63 to 0 location. In this way, our stack pointer moves from 63 to 0 location. Then next step is transfer the content of DR into M of SP. Suppose we have an element Y in the DR register, and we have to perform this operation. Then content of DR means Y is transferred at the 0 location, means Y places on the 0 address in the stack. After that, we can check this condition, means if SP equal to 0, is SP equal to 0? Yes, we can say that our stack pointer is pointing at the 0 location. Next, if SP equal to 0, then set full equal to 1 and empty equal to 0. Initially, we initialize that the full is set to 0 and empty is set to 1. And when we perform the push operation and stack pointer when pointing on the 0 location, we set full equal to 1 and empty equal to 0. This is the third step of the push operation. Let's talk about the pop operation. In pop operation, first the content of M of SP means where stack pointer is pointing out, we transfer the content from the stack into the DR register. Then we decrement the stack pointer register value, means SP minus 1, and if SP equal to 0, then we set empty to 1 and full set to 0. We perform this pop operation on the stack. Let's suppose we are at this location where stack pointer is pointing at the 0 location, and the Y is an item that is on the 0 location. If we pop from this stage, then our stack pointer moves on the 63 address. So we can show this operation by the some mathematical procedure, means 0. First step of pop operation, M of SP transfers to DR, means our Y content item Y is transferred into the DR register. Then second step is decrementing the stack pointer register. Our current stack pointer value is 6 times 0. And we have to perform minus 1. And we perform the subtraction operation in computers by the 2's complement method. So we first write plus 1, that is 0, 0, 0, 0, 0, 1. This is the 6-bit representation of plus 1. Then after that we take the 2's complement. What is the 2's complement? That is 1, 1, 1, 1, 1. This is the 2's complement. So this is the minus 1. This is the minus 1. So we can 1, 1, 1, 1, 1, 1. We add this and result is, that is 0 and 1, 1, 0 and 1, 1, 1, 1, 1, 1. This is the result after SP minus 1. Means this is the result, means stack pointer move from 0 location to 63 location. This is the this operation is performed, and when this condition arises, SP equal to 0 and empty, then set empty equal to 1 and full equal to 0. When we pop item from the stack one by one, then where our stack pointer pointing at the 1 location and item on the address 1 is A. When at this stage we perform the pop operation, then the third step of the pop operation is performed. Let's perform the pop operation from where the stack pointer pointing at the 1 location. First step is content of M of SP is transferred into the DR register. Then A goes from the stack into the DR register. Then we decrement the stack pointer register value, means 1. Our stack pointer value is 1 and we perform minus 1, means 1 minus 1 is equal to 0. It means our stack pointer value is pointing at the 0 location. Then if a stack pointer value is 0, then empty set to 1 and full set to 0. Then again, if we popped item from the stack, then this values set to 0 and this value set to 1. These are the operation on the register stack, where full and empty flags are used for the representing the stack is full or empty, and stack pointer register, that is pointing at the top item on the. So our stack pointer point at the top item on the stack, and full and empty flags shows the stack is full or empty. Basically, data register are used for performing push and pop operation. These are the operations that are discussed in this lecture. These are the push and pop operation, and this is the memory stack. Basically, our main topic is stack organization. In stack organization, there are two types. First one is register stack and memory stack. We last discussed the register stack, and here we are going to discuss memory stack. Basically, in memory, we cannot make a stack of full memory. Why? Because there are some instructions or program are stored in memory. There are some data and operands are also stored in memory. And if we talk about instructions, we are going to use the program counter register that stores the address of the next instruction, and address register that is pointing at the data part, means operand. From address 1000 to 299, 2999, these locations are used for the program instruction part and data part. After that part, from 3000 to 4001, we are going to make a stack in memory, and here data register is used for the push and pop operation, where to push and where to pop, and stack pointer is used for the pointing at the top item in the stack. There is some initialization in the memory stack. First, initialize the value of stack pointer is 4001, means initially stack pointer register is pointing at the 4001 location, and the stack grows with decreasing addresses. Here this is the important point. Stack grows with decreasing addresses. It means when we perform the push operation, our stack, we decrement the stack pointer register. Basically, we decrement the stack pointer register. Thus, the first item is stored in the stack at address 4000. Means our first item, let's suppose our first item is A, that is stored at the 4000 location. The second item is stored at the 3999. Our second item, let's suppose there is a B, that is the second item. It is stored at the 3999, and the last address that can be used for the stack is 3000. Means our last item that is stored in the stack is 3000. So let's suppose X is the item that is stored at the 3000. Here there is a no provision are available for stack limit check. We already show that in the register stack there are two flags are used, that is empty and full, that can show the stack is full or empty. In memory stack there is no flag, so we cannot check the stack limit, that is or overflow or underflow. Stack is overflow or underflow. In this memory stack there is only two operations. First one is push operation, second one is pop operation. Let's talk about the push operation. First step of push operation is decrementing the value of stack pointer register, means SP minus 1. Initially our stack pointer is pointing at the 4000 location, and we decrement the value of stack pointer register, means stack goes 4001 to 4000. Then content of DR is transferred into the M of SP. Means let's suppose A in the DR register, then A is transferred at the 4001 location. This is performed by this is performing of push operation. Let's talk about the pop operation. First, content of M of SP is transferred into the DR register. Let's stack pointer is at this location, and stack pointer is pointing at the 3000 location, and item is placed on the stack is X. 3000 location and item is X. When perform the push operation, pop operation, M of SP, content of M of SP is transferred in the DR register. Means X is transferred into the DR register, means X goes from the stack to DR register. Then content of S incrementing the stack pointer register, means value of stack pointer register is 3000, and we increment by 1, means the value of stack pointer register value is 3001, means our stack pointer goes from 3000 to 3001. This is the pop operation. And there is some important point in the memory stack is that the most computer do not provide the hardware to check for stack overflow, that is full stack, or underflow means empty stack. The stack limits can be checked by using two processor register. One holds to the upper limit, that is 3000 in this case, and the other to hold the lower limit, that is 4001. After every push operation, stack pointer values is compared with the upper limit register, that is 3000, and after a pop operation, stack pointer value is compared with the lower limit register, that is a 4001. In this way, we can check the condition of underflow and overflow. This is the important concept of the memory stack. Thank you. We will discuss next topic in next lecture. Thank you.